So now we get to go over the most powerful data structure we have, which is the map. Let's go ahead and see how we make one. Okay, so the map has a very interesting generic argument, which we'll see in a minute. So map is equal to a new hash map. All right. So this is the interface we'll be using, map, and this is the class that we'll be using, hash map. Now these are, again, extremely powerful. A map, so this will be what, slide 24 for you keeping track. So the map is related to the set because mathematically a map is an ordered pair of values whose elements are known as keys and values. So if you're working from a mathematical perspective, we use this word. We use a lot of words to mean the same thing, and there's some kind of overlap. Like a function can also be called a map in mathematics, right? F of x is equal to 2x plus 1 maps all the inputs of x, to output 2x plus 1. So for instance, if I put in 5 here, this gets mapped to the value of 2x plus 1, which would be 11, right? So you put in 5, you get 11 out, right? You put in 2, you get out 5. You put in 1, you get out 3, right? This function provides a mapping, right, for these values, right? You put this in, you get this out, right? You put this, and we will refer to these as the things you put in as a key and the things you get out as a value in this context, right? Now in computer science, we don't really actually come up with this thing at all. We just simply insert the keys and values together, as you'll see. So if you're thinking of that, this is kind of related to the whole idea of a function in the sense that you've got a mapping between keys and values, these input values and the output values. But we operate it differently. Also, you may have dealt with maps before. These things might be referred to as hash tables sometimes, which is confusing. You might also refer to these things sometimes as, and that's not necessarily a great way to refer to it. You probably shouldn't, because the hash table is what you would use to build it. So maps can sometimes be referred to as, well, maps obviously. In Python we call them dictionaries, or dict for short, D-I-C-T, which are used by the curly braces. And then finally in other languages they might be called associative arrays, which isn't a mouthful, but it is rather long to write out, which is why you often see them just referred to as maps because that's 3 letters, or dict because that's 4 letters. And I'll just be calling them maps here because that's what Java calls them. All right, so what do we do with them? Well, they provide you with a means of mapping some kind of key to a value. And this is a many to one mapping. So for instance, we have these keys over here. We have J mapped to Jane, B and B2 mapped to Bill, S maps to Sam, and B1 maps to Bob. So and so we have these mapping between a key and a value, which seems really abstract and really kind of just what the heck going on here, but bear with me, okay? Now this is, as it says, is an onto mapping, which says that everything in the value has a key, right? All these values have at least one key pointing to it. You don't have a value that just exists by itself. You have to have some kind of key to get a value, right? Values just don't exist in absentia of anything. And rather than adding and the like, we instead put key value pairs into the map, and then given this key, we'll get the value up. So basically, what we're doing is that pretend we've got like a magic bag, and basically we can put anything we want into the bag, and we say, if I say, so the anything being the value, right? So say I've got a magic bag, and the way the magic bag works is that anything you put in the bag, you can immediately summon out of it by saying a magic word. And the magic word for each thing you put in the bag, you determine what it is when you put each item in the bag. So say I put a roast beef sandwich inside this bag. As I'm doing so, what I'm saying is that I can summon this roast beef sandwich by saying the word yummy. So that's the put operation over there. Yummy would be the key, the roast beef sandwich would be the value. And so then I can retrieve that roast beef sandwich by saying yummy. Okay? Now, in less kind of fantastical terms, the key is something unique. What we use is that we use some kind of really unique key to map that key to a whole bunch of other data, right? And this is typically how you might get something stored in like a database or something. You'll have some kind of unique key. So say, for the sake of argument, that you are a university student. Hard to imagine, I know. Now, as a university student, you should have probably gotten some kind of student ID, and you may have noticed that you have a student ID number. Now, this is not just because you are some small cog in a giant university machine, although it may feel like that sometimes, but it's actually because we need that to look you up and look up your information. It's not sufficient for us to look you up by just getting your name. Right? If you give me your name's probably not unique. For instance, when I was in middle school, I entered into 6th grade, and a lot of teachers and a lot of other students asked me, hey, were you related to this other Andrew Rosen who had just graduated the same middle school the year before I entered? Really weird. So my name was definitely not unique. And, you can't really assume anything about somebody's name. It's actually absurd. You cannot really make any kind of assumptions about people's names. That two people with the same name would not live at the same address, right? Or that they would have the same major. So, right, and then from our perspective as members of a university, we can't accidentally give you out some other student's information, because that would be a FERPA violation, so that'd be bad. So instead, to make this a lot easier for us, we have your student ID number. And so we ask you to provide us with your student ID number whenever we have to look up information about you. And that unique number, which is assigned to you when you enroll in the university, will provide us with all the relevant information, rather than trying to look up the student name and getting all the other information. Similarly, if you are a customer for a big online store, hard to imagine that scenario, right? You'll probably provide some, like Amazon or one of their many competitors, with an email address. And that will be the key for all your customer information. Why? Again, you might have multiple accounts for one, so that kind of associates you from one account to another. You also might have a name, right? But you might be shipping to a different address, not your address. You also can have the same name as many of the other billions of customers in the world. It's certainly in that company's best interest to prevent you from, trying to buy stuff with with somebody else's credit card, right? So really, what makes one customer unique from any other customer is their email address. So that's why you use your email address to log in, or if in other cases a determined at the time you create your account username. Okay, so that's why. So these kind of things are the keys, and the values actually would be like an object that contains all this stuff, or an object that contains all this stuff, or a part ID which contains all the information about the description, the quantity, the manufacturer, the cost, and the price. Right. So the key is typically something simple, and the value can be something a bit more complex.